So today's notes, we're looking at equivalent equations. How can I rewrite equivalent equations? You would rewrite an equation to transform it to make it kind of easier to solve, but we're going to look at that process prior to solving, just in practicing rewriting them. We want to make changes to both the left and right side of the equation and be able to kind of manipulate those with properties. Now this notes template has two warm-ups at the top. You can leave those blank. You're going to do those in class with your teacher. So you're going to leave the warm-ups blank, and we're going to move down to the definition spots. So equivalent equations are equations that have the same solution set over the domain. So it just means they have the same solutions to them. So that's equivalent equations. And again, equivalent equations have the same solution set. So when you're trying to find a solution, you can kind of transform an equation or change an equation in order to make it easier to solve. So you transform an equation to change it to make it easier to solve. There are certain types of transformations that we make, ALE, MLE, distributive, that will help us to solve. So we can transform with ALE, addition law of equality, and that just means we're going to be adding something to both sides. We can transform with MLE, the multiplication law of equality, and that means we would be multiplying something on both sides of the equation. And these create equivalent equations. So there's a change to both sides. It creates an equivalent equation. When you make a change with distributive property, that just creates an equivalent expression. And the difference there is that the change is only on one side. Thus, the expression versus the equation. So in this first example, we're looking at determining how each equation was transformed. Now these transformations are not necessarily what we would do to solve, because right now we're just kind of looking at changes. Whether these would be changes that we would actually use in a situation is going to depend on the equation. So what I'm asking you to think about is what changed from the first equation to the second equation listed. So this is our given equation, and then we change it to 3x minus 1 is equal to 15. What happened to go from the first line to the second line? And what happened there was an ALE. You added something to both sides. We added plus 5. So it was an ALE of plus 5. Now what happens to go from this line to the next? And that happens to be a change of MLE. We multiplied every single piece by 1/3. And that's a little bit harder to see, but if you kind of take a look, that if you would be multiplying by 1/3 on every term on each side, we would get the resulting equation. So you're trying to think, how did it get to the next equation, to identify the transformation. In example B, again, we've got our given equation, and we're looking at changing it into the next line. So you're looking at what change occurred from the first equation to the second, and hopefully you notice that on the right-hand side, nothing changed. So that is going to be a change of just one side, or an expression, and that is actually a distributive change. What happened there was distributive in reverse. We factored out a common factor of 4. So we kind of pulled out a factor of 4 from both terms on the left-hand side. All right, given this equation where we had distributive, now we're looking at what changes to get to the next line. And hopefully you can see that that is a change on both sides of the equation, so it needs to be an ALE or an MLE. And what happened there was an MLE of 1/4. Because we divided each side by 4, or we multiplied each side by 1/4. Then, looking at the change, going to the next line, and if you have x plus x minus 2 and you end up with x minus 6, hopefully kind of thinking, okay, that looks like adding -4, and then you'd have to check that on the other side. When I have 9/4 and I add -4, all right, so I've just shown a little work below there, kind of going through that thought process, that if I have 9/4 on the right-hand side, and I add -4, but of course I'm putting that in fraction form so that I can add my fractions, it does give me -7/4. So that tells me that this is an ALE of -4. So in the next part, we're going to kind of practice the transformations given a transformation. So we have our given line of 9x plus 7 equals -12, and you're asked to do a transformation of an ALE of 2. So that means we're supposed to add 2 to both sides. So I'm just going to jot down +2, +2, kind of showing that on both sides of the equation. And then I would write what is the result. So I end up with 9x plus, and then 7 plus 2 would give me the 9, and -12 plus 2 would give me -10. So that was an ALE of 2. Going down to the next line, I'm asked to take that previous equation and perform an ALE of -3 or -3. So I'm adding a -3 to both sides. Again, we're just going to change the one above. Let me switch colors here. And so I end up with 9x plus 6 is equal to a -13, and that's the ALE of -3. In the next line, I'm asked to apply an ALE with 12. So I take the previous, so I've just got it written there, but you should have it on your worksheet. And I'm adding 12 to both sides of the equation. So I should end up with 9x plus 18 is equal to -1. Now the next change that I'm asked to, or next transformation I'm asked to do, is a distributive. Remember that distributive is just a change on one side of the equation. Not much to change on the right-hand side. We only have one term of -1. But distributive here is, I'm going to try and look for a common factor in the two terms on the left. Now this is going to be what we kind of look at as a reverse distributive. You're factoring out a common factor. So what factor do 9x and 18 have in common? Well, they have a factor of 9. And if I would pull that factor out, I would be left with x plus, and then 18 divided by 9 is 2. And so that's kind of a reverse distributive. In the next line, I'm asked to apply an MLE of 1/3. So that means I'm multiplying both sides of the equation by 1/3. This is all one term, so I'm just multiplying that one piece by 1/3. 9 times 1/3 will give me 3, and the x plus 2 stays because that's all one term, one factor. And then here I would get a -1/3 as my result of -1 times 1/3. And that's applying MLE. Again, applying MLE, but this time of -1/2. So I'm going to multiply both sides by -1/2. Again, this is all one term, so just multiplying the one piece. So I get -3/2, and that's being multiplied by the x plus 2. And here, on this side, I get 1/6. So just kind of practicing applying those different properties. Right, we're going to continue to practice the transformation. So with this next equation as our given is 1/3 t plus 5 equals -3. I want you to apply an MLE of 3. Now while we're doing these practice problems, it might be a good idea for you to just pause, do the problem, and then continue the video so that you're kind of giving you a chance to do the problem and then check with what I have. So go ahead and pause, do the first one with an MLE of 3, and then check. So when I multiply both sides of this equation by 3, I have to watch because I have 2 terms on the left and 1 term on the right. And when you're applying an MLE, you have to make sure you apply it to all the terms. So I'm multiplying by 3, but I have to multiply each term by 3. That's going to give me t plus 15 is equal to -9. So again, just watching that you're applying the MLE to all the terms. MLE of 1/2, I've got to multiply that again by each term. So I've got to multiply by 1/2 to each term and on each side of the equation. So I end up with 1/2 t plus 15/2 and then -9/2. And there's different forms that you could write that in. If you wanted decimals, you could do that as well. I like to leave things as fractions when I'm working algebraically. For the next transformation, I'm going to transform with an MLE of -2. So I want to multiply each term by -2 on each side of the equation. That would leave me with -t, or -1t, plus -15 is equal to 9. Then continuing, I'm going to apply an MLE of -1. Again, that means I want to multiply each term on each side by -1. So that's going to give me t is equal to, t plus 15 is equal to -9. And for the next one, MLE of 3. So that gives me 3t plus 45 is equal to -27. Again, each of the equations would have the same solution set. We're just transforming them. Equivalent equations have the same solution set. All right, looking at the next one, we have a change of distributive. And remember that distributive is just changed to one side of the equation. So I'm going to keep the right-hand side the same and just change the expression on the left. So I'm looking with distributive for a common factor to either distribute or pull out. This is going to be a kind of reverse distributive pulling out a common factor. So you want to think of a common factor between 3 and 45. And that would be a factor of 3. And then inside the parentheses, I would be left with t plus 15. Again, that is that reverse distributive. So what I'm thinking of is just kind of going, if I would go backwards, I would get back to the 3t plus 45. So I'm pulling out that common factor of 3. And then the last transformation I'm asked to do is to apply an ALE of -6. So I want to make sure then I'm adding -6 to both sides of the equation. Of course, that's just adding ones to each side. So on the left, I keep what I had prior, and I'm just adding a -6 to it. And on the right, I can go ahead and do that addition, and I get -33. So just some hints to be successful at this. When you are dealing with ALE, typically you're going to deal with that outside of parentheses. MLE, you need to apply MLE to each term. And so that's going to mean each term without parentheses, because if it has parentheses, it's all one term. So that's kind of understood as you kind of get more comfortable with algebraic expressions. And so MLE, if there are parentheses, it's all one term, so you would keep the MLE outside of the parentheses. Just some hints there. Take any questions into your teacher.